Hello everybody, today we're going to be talking about how at Sovereign we set up for a brand new form. Specifically, we're going to be talking about how we create a brand new SharePoint FX web part, SharePoint Framework web part, some of the tools that we have available to us inside of our solution, how we go about using those tools, utilizing them, setting up for a brand new web part, setting up for a brand new form, and so let's just jump right into it. The first thing that I want to talk about is kind of our starting point, the assumptions that we're making as far as where we are currently. First thing that you'll need to do in order to make this work is to go through the tutorial that is put out by Microsoft on this website that you see here on setting up your development environment. Some of the things that that's going to do for you is get Node.js installed on your computer, Visual Studio Code, Yeoman, Gulp, and walk you through the procedure of trusting your dev certificate so that you can run an HTTPS website from your local host without getting any kind of errors. Some specific things that it's not going to talk about but that we need to do as well is install the npm package npx. We'll get to this in just a minute, but this allows you to run very specific versions of npm packages and npm commands, which we're going to have to do in our environment because we are developing against the Salt Lake City SharePoint, which is on an older version, and so if we use the latest version of the framework tools and framework code, it's not going to work. So we're going to use npx to allow us to install older versions of the tools and run older versions of the command so that it's compatible with the production environment that we're going to be using. After you get all of that set up, you're going to have to go get our code. We're going to be working inside of an existing solution that has a number of these tools that I talked about earlier and allows us to utilize some shared code among our different forms and web parts that we have set up. So this is the address for that. You can use any kind of get tool that you want. There's a get tool inside of Visual Studio, or there's winget or different things, but go clone this into your local machine and use this kind of as a starting point for creating a brand new form. So, as I said before, we're going to use npx to install specific versions of the libraries that we're going to be utilizing. It doesn't install them directly onto your, well, it doesn't install them permanently onto your machine. Instead, it will download the files that are necessary, install them, run the command that you want to run, and then clean itself up afterwards. So it's a really nifty tool that allows us to do that. How exactly do we go about doing that? We use certain flags. The P flag is what package we're trying to use. So in this particular case, we're going to use npx. We're going to get the package yo or yeoman, and we're going to get the Microsoft generator package version 1.7.1. Again, this is the version that is compatible with the Salt Lake City environment and the version that we've used to build all of the other forms, and so we're just going to continue to keep using that version of the generator for consistency among all of our forms. The last thing that we're going to do is we're going to give it a command. So after we've installed that version of yo, after we've installed that version of the SharePoint generator, then we're going to give it the command yo, run the SharePoint generator. So switching over to the code to give you some kind of example of how exactly we're going to do this, I'm going to take that command that we just showed and we're going to go ahead and run it. This is going to take a minute while it does all the things that I talked about. First it goes and it checks the version of yo. In our particular case, the version of yeoman that it would download is the same as the version that I have locally installed on my machine globally. So it's not going to do anything regarding Yeoman. It's just going to use the package that I already have installed, but it knows that I've got a more recent version of the SharePoint generator, and since I asked specifically for version 1.7.1, it's going to go ahead and download all of that. So we'll give it just a minute to download the generator and then run that command, and we'll see where we go from there. So that is finished. So now we're going to run the yeoman command for the Microsoft generator. We want to create a web part in our current solution, so we'll go ahead and do that. We're going to use for our example the new punch list form that we're going to be developing. So what is the name of the web part? We're going to call it punch list. The description, you can use whatever you want. Not very many people will see this, but you can either leave it the default, which is punch list description, or punch list web part form. Again, for consistency's sake, the JavaScript framework that we're going to use is React, just so that it matches all of the other web parts that we've built up to this point. And we'll go ahead and let that run for a little while. Yeoman is a templating software, so if you've ever used the full version of Visual Studio before, and you say like File, New Project, and then it asks you to choose a template, web projects, C# projects, whatever, and then it installs a whole bunch of files for you to kind of help you get started with that particular project. Yeoman is a very, very similar tool. It's just a free version rather than the Microsoft-specific version. So what it's doing right now is it's going and creating a bunch of files inside of the project and modifying some of the other files that we have to help us get set up with a brand new web part. It just does a bunch of boilerplate code for us. That is finished. Let's go take a look at exactly what it did here in our code. So if we look over here on the side, this is the solution that we've downloaded. It's made a couple of changes for us. Most of the changes I'm about to show you, you don't really need to worry about, but I just kind of want to show you what it's doing. The first one is in the config folder. We have a config.json. This is something that tells SharePoint how to interact with our code. So when we install this solution inside of a SharePoint environment, it needs to know what the web parts are, what code in order to run, when you put a web part on the page, where to start, that kind of a thing. And so this config.json is what does that for us. And you'll notice that down here at the bottom, because we created a new web part called punch list, it's created a punch list web part and filled in some of that information for us. The next thing that it did for us, and most importantly, inside of our web parts, or inside of our source folder, web parts folder, we now have a new web part. So each one of these folders represents one of the web parts that gets installed when we install this solution into SharePoint, and it has created a new one for us. It's created this punch list folder for us, which is this new web part that we have created. It's given us two files, a punchlist.ts and a manifest.json. That manifest is what's read by our config file that we just looked at, and most of the time you'll never need to look at this. This punch list web part that we have right here kind of tells SharePoint how to, it allows communication between our web part and SharePoint that it's installed on. So some of the things that we can do for us is we can use this to set up the property pane. If you've ever put a web part on a page and you click edit that web part and the little property pane comes out from the side, gives you options to change how it looks and feels, things like that. We can build our own custom property pane and use the properties that are in there inside of our actual web part. The other thing that happens is that this particular page, this particular interface, I guess you could say, is given a context. So we can ask SharePoint questions about the environment that we're currently in. For example, we could say who is the currently logged in user, or what is the root web of the web that I am currently on? What is the server relative URL of the page that I am currently on? So we can ask SharePoint questions. We can ask about roles and permissions and things like that. And that gets passed to this page, but it doesn't really go any further unless we explicitly tell it to. So one of the very first things that I do whenever I build a brand new web part like I'm doing right now is I come in here to this element, and so we're going to create something called a punch list, and we're going to pass it punch list properties. The only property that we have right now is the description. That's going to come from our property pane, but the next thing that I want to pass into it is a context. This context. Now you'll notice one of the fun things that we have going on right here is I'm getting the little red squiggles that says, hey, there's something wrong with your code. We're not actually using JavaScript, we are using TypeScript, and one of the biggest differences between JavaScript and TypeScript is typing. JavaScript is a loosely typed language, which means you can assign anything you want to any variable that you want, and JavaScript will just try to run with it and figure it out on its own. TypeScript is a library that runs on top of JavaScript that allows us to define specific types for some of our variables. So what's happening right here is we are creating a punch list, and it knows that this React element wants, called a punch list, wants punch list properties. And so then we're trying to pass that in, which has a description and a context. But if we were to mouse over this, it would tell us essentially, hey, you're trying to create a punch list property type, and you're passing a context in, and it doesn't know what a context is. So we have to go teach it. So I'm just going to click on punch list properties right here and hit F12 on my keyboard. That's going to take me to the definition of punch list properties. If you also want to know where that is, because we're going to come back to it, inside of our folder structure again, we have source, web parts, punch list. Inside of that, we have a components folder. Inside the components folder, we have a property file, and that's where we are right here. So we need to tell it, in addition to the description, it's also going to have a context that is going to be of the type web part context. Now, TypeScript itself doesn't know what a web part context is. TypeScript has a number of definitions available to it. It knows what a string is, it knows what a Boolean is, it knows what a number is. A lot of those things are built in. But things that are more complex, especially complex objects, it doesn't have a definition for. So we have to import that. You'll notice that my IDE did it just when I hit tab. If you're using Visual Studio Code, it might do that for you as well. You might have to click on it and do a control dot to give you the option to import it, or you might just have to memorize this code right here, import web part context from web part base. But once you do that, now it knows that a punch list property, or punch list props, needs a description that will be a string, and a context that is a web part context. So we can go ahead and save this. We'll come over back to the page that or the file that we were just in, the punch list web part, and you'll notice the red squiggly has gone away because now it knows that a punch list props wants a description and a context. Another nice thing about TypeScript is that it's able to compare types. It knows that this .context that we're looking at right here is a web part context. So for example, if I were to come in here and say a string, it would give me another red squiggly. Again, I didn't save it. There's no compile time. I didn't have to run anything. This is on the fly editing. And it says, hey, type string is not assignable to type web part context. So it knows while you're writing your code what it expects of you, what you expect of it. So we're going to go back and say this, context. Oops. And now everything's fine. So most of the time when I'm working on my code, that's about all I do to this file, and then I never come back or look at it again. What we're going to look at is inside of our components folder. We're going to look at the three files that we have here. The first one we've already looked at a little bit. We have a punch list property interface in here. Interface is just another fancy word for definition. So anytime we use something called an iPunchlist props, it's going to be defined by needing these. We're going to go ahead and create one more that we're going to need. And again, this is something that I do for just about every web part that I create. We created an iPunchlist state. I'll explain a little bit more what that is in depth later on, but just know that it's something that 99% of the web parts that you make are going to need. And so I just go ahead and set that up very first thing while I'm here. Second thing that I want to look at is our main file. The vast majority of the time that you're writing SharePoint Framework web parts will be spent in this file. This is where we're going to do all of our work. This is where we're going to do all of our rendering, all of our logic. Just about everything is going to be in here. The only exception to that is going to be this module.scss file. If you're familiar at all with CSS, this is going to look very similar to you. So we have a class definition of punch list, and then we define what goes inside of that. Some of the things that set it apart and make it really cool and different is that you can have nested definitions. So for example, we have this punch list. Then inside of that definition, we have another definition that is container. So the CSS properties that we assign right here are only going to be applied to containers that are children of punch lists. This makes SCSS really, really nice for compartmentalizing. For example, I could go ahead and create a header object, or a header definition, and say that I want that to be font size 1,000,000 pixels or something like that. And this will only apply to headers within my punch list div. So I don't have to worry about one of the most common things that you'll run into when working with CSS, and that's clobbering global definitions. There's a lot of times where you'll want to create something called a header or something called a row or whatever, but you only want it to apply to a specific part on your web page. And so you'll go create that row or whatever and then realize that somewhere someone else has created a row and you've now clobbered their definition or they're clobbering you. And so then you end up coming up with really strange names like, punch list header top nav v1 or something like that, and then you have all these crazy class names scattered throughout your code. But with SCSS and less and some of the other similar technologies out there, we don't have to worry about that. Because of this nesting functionality, one of the things that I personally like to do is I just define everything within something called a wrapper. So I'll call this punch list wrapper. And then on my, oops, lost it. In my primary code, I will make the uppermost div punch list wrapper, and then I will define everything. I will put all of my HTML, all of my markup, all of everything inside this punch list wrapper, inside the CSS file. I will put all of my definitions inside the punch list wrapper, and then I just don't have to worry about any sort of conflicts with anything else that's happening on the page. I know that it's all going to be contained to what I want it to have. So that's some of the initial things that I do to set up a web part, go through Yeoman, make a couple of those basic changes, and now we actually have a web part that we can test, run, and look at. So I'm going to come down in here. You're going to be using this command arot. This is gulp serve. We'll go ahead and run this just to see if we actually did our job right, if anything actually shows up on the page, see if we've made it correctly to this point in our presentation. So after the gulp serve command finishes, we'll notice two things about what it's done for our machine. The first is it has created a Node.js server for us that is currently running on our machine. So we're going to be able to look at web pages served on localhost because we have a local web server running. That also means that this command will never end of its own accord. In order to be able to stop the server and continue doing things, we'll have to hit Control-C in order to crash that server. And the second thing that it does for us is it opens up a web page. This web page is looking at that localhost Node.js server that I was just talking about and takes us to a specific page within that server called Workbench. This Workbench page is something that comes when we install the Microsoft generator on our machines, that Yeoman thing that we did earlier, and gives us a page that is supposed to very strongly resemble a live SharePoint Framework modern page. If we click on this plus button right here, like we would on a SharePoint Modern page, it gives us all of the web parts that are available to us. Because this isn't an actual live server, we don't see any of the live web parts that you would normally expect to see on a SharePoint server. However, what we do see are the web parts that are part of our solution that we're developing right now. You'll notice that we just created one called punch list, and here it is showing up in our list. So if we go ahead and add the punch list web part to our page, you'll see that we get this welcome to SharePoint, customizing experiences, and punch list. Now you'll remember what I said earlier, that we have access to the property pane. So if we hit edit right here, we can see that description field that was in our property pane. We can come back again to this page right here. This is our property pane configuration. We have a group. This is our property pane configuration. We have a group with the basic group name. We have a field called description, and that description gets passed into us as a property. Now, if we go and look at the actual component we have right here, we'll notice that on this line, we'll see that we have this properties. So those are the things that are passed into us. And right now that properties will have two things associated with it. So we'll have this properties description and this properties context, because those are the two properties that we got passed in from our parent object here. Now, if you're putting things together in your head, you'll realize that this description comes from the property pane, gets passed in, and then gets output to our screen right here. So if we come back to our web part, theoretically, we should be able to change what's in our property pane description right here. Hi, Mom. And as it gets passed in as a property to our web part and gets displayed on the page right here, all in real time, without saving, without updating like we used to have to do with classic SharePoint pages. The next thing we're going to be talking about today is rendering, or, as you can see the subtitle we have right here, putting stuff on the screen. One of the most important parts of building a web part, building a form, doing anything in these kind of SharePoint customizations is being able to put stuff on the screen. So I figured we'd go ahead and start there. Um, the way that that's referred to in React web parts is rendering. So let's go ahead and look at how we do that, how things got onto the screen. We touched on it a little bit at the end of the last video when we were talking about the properties description, but we're going to go to quite a bit more detail here in just a minute. So switching back to the code. Every single React component that you ever build has to have a couple of things. The first is it has to have some properties that are passed into it. Without any properties, it won't build or compile or do anything. And the second is that it has to have a render function. This essentially is the answer to the question, what do I put on the screen? Just as a bit of a refresher, if we were to go back to our main page where everything starts, all this main page is doing is it's creating an element. It is creating an element of type punch list. It's passing some properties into that element, and then it's rendering that element onto the screen. In React, they try to follow this pattern as much as possible. Everything is components that have children components associated with them, and those components can have children components of their own, and those components can have children components of their own, and it allows you to really compartmentalize a lot of your code and keep with the one job principle. A single component should have a single job, and if it starts getting too complex, you can break that out into other components and have many children components that all get together to make up a single larger component. Depending on the complexity of your project, you may do that, you may not. But what we're doing here is we are creating a single element, a single component, and we are rendering it to the screen. Now, how does it do that? Well, this is a child of something else, and since it is a component itself, it has to have a render function. So when something calls punchlist web part, namely SharePoint, it asks it, hey, what do you need to do in order to put yourself on the screen? And its answer is, well, I need to create this element, and I need to write that element onto the screen. Okay, great. So then this is going to ask the punchlist element, hey, I'm about to put you on the screen. What do you need to do? And its answer is its own render function, which in this particular case is, oh, I want you to return an element that is a div, and it has a child div, and it has a child div, and it has a child div, and so on and so forth. And so eventually you're going to return this entire thing as if it was a single element. No matter how many children are in it, it has to be returned as if it was a single element, and then that answers the question, how do I draw myself on the screen? We can see this, that it has this wrapper that we talked about briefly earlier, and that is the outermost div of this return function. If I were to go and try and create a sibling of it, it gets really mad at me because it says, hey, the render function can only return a single element, and right here you're trying to return this div and this div. That is two elements. It is not allowed. Have a nice day. You cannot return siblings in any kind of return function like this. But once that goes away, we're returning a single element. No matter how many children it has, it's still a single element. Life becomes good again. Now, again, as part of the initial setup that I typically do with all of my SharePoint Framework web parts, is I'll go in and just blow up all of this introduction code that we get from Microsoft. And I'll come in here to the SCSS and blow up all of the code that they give us right here. This gives us a nice clean slate to start with. We have a punch list wrapper. Sometimes you'll see this warning right here, this yellow underline is a warning. That's basically saying, hey, you're defining something called a punch list wrapper, but you're not telling it to do anything. So just as a placeholder to make the warning go away, I'll just do display block. That really shouldn't affect anything, but at least it gets the warning to go away. So congratulations, warning's gone. All this boilerplate's gone. Now we have a nice, empty, blank web part to work with. So what is the first thing that we need to do in order to start writing our web part? Well, because this is going to be a form and we want it to look very similar to our other forms, I'm going to use as an inspiration another web part that I wrote. This is the budget reallocation web part, and we are going to try and recreate this top header section right here. We're going to try and give it a title. We are going to put this image on it. For now, we'll just ignore this middle part. We'll leave an empty space there, and we're going to put these buttons off to the side. So how do we get started doing that? Well, because I know this form is going to be very long and it's going to have lots of different sections that need to be rendered, I'm actually going to, very first thing, break out this particular section into its own block of code. So I'm going to create a new private function. We don't want anyone else to have access to this because it only exists for the purpose of rendering this one form. My personal convention is I do an underscore in front of all private variables and private functions in order to show that it's private. We're not going to share it with anybody else. I'm going to use the word render because what I would like this to do is to help the render function. I would like the purpose of this function to be able to put something on the screen. And so in keeping with React's convention of render being the answer of how do I put things on the screen, I'm going to continue using that word. And what do I want to render? I want to render the header row of our punch list form. So I have a variable called render header row. What is that variable? Well, it's a function. So I'm going to use this parentheses notation to show essentially what type of variable it is, that it's a function. And I'm going to use colon to say what is this function going to return. We are going to return a single element, again keeping with the convention that we have from our React render function. So I have a variable that is a function. It returns a single React element, and now we're going to use what's called the fat arrow notation to define it. And that is just an equal then, greater than sign. So variable that is a function that looks something like this. Now you'll notice that already I have an error showing up right here, and that's saying that you have a function defined that is supposed to return an element, and it's not returning an element. Oh no! You cannot return void or any. So to get that to go away, we're going to say, hey, this is going to return, we're going to return just an empty div for now, and then that goes away. So one of the things that we're using in order to make our web pages look really, really nice is a library called UI Fabric. UI Fabric is put out by Microsoft, and its specific purpose in life, one of the things that it was supposed to do, is allow you to build web parts that look like SharePoint. That's the reason that I use it, because we're putting this web part in SharePoint, so we want it to kind of look like SharePoint does. So if we put a text box on the screen, or a checkbox on the screen, or text on the screen, or different things like that, we can utilize what SharePoint is using, because they actually build SharePoint using UI Fabric. So if they're using UI Fabric to design their elements and we use UI Fabric to design our elements, theoretically once we put it on the page it's going to look very, very much at home. One of the things that we get from UI Fabric is something called a grid. Now, many other libraries that are similar to UI Fabric, such as Twitter's Bootstrap, have grid layouts as well, and they all kind of serve a very similar purpose. And that's best described on their website right here. If you go do a Google search for UI Fabric or something like that, it should bring you somewhere close to this page, developer.microsoft.com, ENUS, Fabric. And there's a getting started page, a styles page, controls, different things like that. We'll be using a lot of these things and referring to them as time goes on, but what we're interested in right now is the grid. So once we put a grid onto our page, it kind of tries to divide the page up into 12 different sections. And we can tell it how many sections we want things to take. So you can see the grid right here, 12 different sections across. So this is about how big it would be if we told each thing to be one section, if we told each thing to be two sections. In our particular case, because we're trying to divide our page up into threes, we're going to have 1/3 of it be this image, 1/3 of it be this blank space in the middle, and 1/3 of it be these buttons over onto the side. We are going to define a grid, and we are going to split our row in that grid into 3 different sections that are 1/3 long, or 4 units wide. Now I already have a lot of these definitions set up for us. This is one of the first times that we're going to be able to reuse some code that we get from importing our project and rather than starting a brand new web part, using the project that we have, because I've specifically designed it to have a lot of shareable code. That was a terrible way to say that. Now, one of the reasons that we started by cloning the repository that we have and using our current solution, as I mentioned earlier, is so that we can have reusable code, so that we can have things that we can share in between our different components. And one of the things that we can do share in between our components is this grid setup that I have right here. So if we come into common components, so again, we're in our solution file over here, we have our source, common components. You'll notice that I have a common interfaces and a common module. In common module, we're importing the UI Fabric core definitions, and then we're setting up a bunch of different classes that use those definitions. So you'll notice that some of the words I used earlier is we have a grid. Inside that grid we have rows, and inside that row we have columns. I've defined these a little bit and given them a little bit more robustness than comes out of the standard Microsoft library and called them by slightly different names. So if we wanted to have a 12 wide column, we wanted that to be the full column, then I've defined a definition right here called full column. If we wanted to split it into, say, halves, we could say this one is only half the column, so I've created one called half column, third column, so on and so forth. You can go ahead and look at that at your leisure and see how many different definitions that I have. But we're going to go ahead and just import this entire file, and then we'll be able to use all of these different definitions and share them among the different web parts and the different components that we create. So I'm going to come into my punch list file right here. I'm going to create a new import called common styles. And then where are we going to get that? It's going to come from above us, above us, above us, common components, common.module.css. So now we have access to all of those common styles. So the first thing that I want to do is set up the entire page, the entire web part, to be a grid. So in our little wrapper div that we have right here, in addition to calling it a punch list wrapper, we're also going to add a space and give it the definition of common styles grid. Now that's going to allow us to use our grid components and set things up nice and space them nice and even for us. So inside our header row, what we have right here, we're going to use our class name again. Whoa. Actually, maybe I'll go with that for just a minute. One of the reasons, if you're used to HTML, you'll notice that rather than using div class equals my name, all of these are saying div class name equals. That's because class is a reserved word in React, and as a reserved word, we can't use it in any other places. You'll notice if I do class, oh, it's not going to do it for me anymore. Anyway, class is a reserved word, so if I were to say class equals something something right here, then TypeScript would freak out because it thinks I'm trying to define a new public class inside this div, and it doesn't know how to do that very well. So something that you just have to learn, have to know, have to memorize anytime you're using React and you're building these HTML-ish elements, you have to use class name. So we're going to use class name equals, and then because we're using code in this class name, we have to put it in brackets. This open bracket, close bracket notation right here is pretty much your clue, your indicator anytime you're working in React that this is going to be code that will eventually be interpreted and compiled, as opposed to just being standard string definition. So we could come in here and say class name equals ms grid or something like that, and that would just be put directly on the page as it is because it's a string and we don't have to worry about it. However, because we're using code, we're using variables, we're going to put it in brackets, and we're going to say common styles row. So this is a new row that is going to show up in our grid. And as a row, we're going to have 3 different parts to it. So 1 div, 2 div, 3 div. We want each of those to be 1/3 the size of the row. So we're going to use our common components again. Common styles, let's see, third column. Hey, there we go. That looks like it'll be helpful. So that should take up 1/3, that should take up 1/3, that should take up 1/3. And say hi mom, hi dad, hi son. We'll put each of those in there, and we'll go ahead and take a look at that on our page. Again, you don't want to go too far in writing code without actually checking it to make sure that it compiles, make sure it does what you think it's going to do, make sure it looks nice. So always, always frequently check your work. Now, if we come and look at what we have on here, we have nothing. That's because we made a mistake. While we did come in and define this render header row, we're not actually calling it or using it anywhere. So when SharePoint says, hey, render this component, it says, okay, I'll give you this div, and stops. So we're not actually seeing anything on the page. So again, we'll go into code by using this open close bracket, and we'll just say put right here whatever the return of render header row is. Now we know that that's going to work because this is returning a JSX element. So much like a component has a child component and says how do you render yourself, and it returns an element, we have this component that has a function that returns an element. And so all we're doing right here is saying essentially put whatever element this returns onto the page. So this is kind of a shortcut way of creating child components that do very, very simple tasks. If we wanted to, we could actually go and create a whole new component called header row that returns a render function. And then when we come in here, we would say put the header row component on the page. But that's a bit overkill for something as simple as what we're doing right here, so this is kind of a shortcut way of doing it. But as long as you keep that in your mind, that that's a way that we could do it, and get yourself into the mindset of thinking this is a child component, this has a child component, this has a child component, we're going to break things out into these little children, it'll help make your React experience much, much better. So now that that is recompiled and re-rendered, you'll notice that we have our 3 divs right here, hi mom, hi dad, hi son. They all take about 1/3 of the row that they have available to them. And we didn't really have to do a whole lot of work for that. One of the other nice things about that is that 1/3 that they have is responsive. So if we take this page and shrink it down, you'll notice that the amount of space that they have gets smaller and bigger depending on how much space they have to take up. And if we get too small, once we get below a certain threshold, they just nicely and neatly stack on top of each other. That's some more of that robustness that I said I've added in as an afterthought. The grid itself doesn't do that normally, but because we're using the common definitions that I've set up, they'll stack on top of each other quite nicely most of the time. So with very little work, very little effort, we've got something that looks pretty good on a web browser and something that looks decently good on a phone. You don't have to scroll side to side in order to make that work. So in the place of this hi mom right here, we want there to be an image. And for the sake of time, I'm going to cheat a little bit since I know that image already exists in our budget reallocation form. I'm going to run into budget reallocation really fast. I'm going to find this logo image. I'm going to steal the code. And not you. You. And we'll define it right here. So this is saying we're going to create a variable that will never change. It's a constant variable. I'm going to call it logo image. I don't really care what type it is, so it can be anything. And I'm going to go and get this file right here. This file is also going to be in common components. Very similar to this one right here, but it's in a folder called resources, in a folder called logo. So now whatever this file returns, which is going to be essentially a big collection of bits, is going to be stored in logo image right here, and we're just going to take those bits and drop them right on the page. Now, did that get us what we wanted? No, it didn't. Instead, it got us a path to that particular image in our localhost distribution folder. So we have a path, but not the actual image. So how do we turn that into one? Well, we're going to use another UI Fabric component. We're going to use the image component. Now, components in React look very much like complicated DOM elements. So when I say we're going to create a child element and put it on the page, much like we created a child element called a div right there, we're going to create a child element called image right here. You'll notice that the way that I did that was very much the same, except instead of typing the word div, I typed. So when we put this on a page, you'll see this red squiggle right here that says, hey, I don't know what an image is. And again, for the sake of time, because we have this somewhere else, I am going to go and steal the definition of image. So we're going to import two things, an image and an image fit, from our Office UI Fabric React library. We'll go ahead and add this up into our definitions up here. And now that goes away, it knows what an image is. Again, we can go look at the documentation for that inside of our Fabric UI page. But for the sake of expediency, and because I already know what it needs, we are again going to go steal some information from there. So the first thing that I want to do is I want to turn image into a self-closing tag rather than an open tag like this. So I'm going to delete the close and put the close right here. Now we're going to pass it 3 parameters. Again, very similar to what we saw on our previous page where we said, hey, create a punch list element and pass it a description and a context. We're doing very much the same thing here. We're creating an image element and we're passing it a source, a fit type, and a class name. Right now I don't actually care about the class name. We don't have that defined. So the source is going to be our logo image. Remember when we just dropped this logo image on the page earlier, it just gave us a location of the image. It didn't actually give us the image itself. So we're going to use that location and say, hey, this is the source of our image. The next thing that we're going to do is give it a fit. You'll notice, remember that when I imported this definition, I imported the definition for image and the definition for image fit. Image fit is nothing more than an enumerator that has different ways that we can try and shrink or stretch or cover the image in the space that it has. I'm going to tell it contain, which essentially is going to try and smush the image into whatever space it has. So if I put it inside of a 100 pixel by 100 pixel box, it will try to fit as much of the image as it can inside that 100 by 100 pixel box by shrinking or growing or stretching the image as much as it can. So we have our image child element, we have the properties that are being passed into it, and you'll notice that in a lot of ways this looks very much like just another HTML tag that we have on our page, and that's kind of the point. This JSX element allows us to try and get the best of both worlds, to be able to make things that look and feel very much like standard HTML while giving us the power of being able to use code and variables and complex components inside of it. So if we come back here to our workbench page, it did not put the image there. So we can use our debugging dev tools to try and figure out what went wrong. So I hit F12 to open up our developer tools. This shows us the HTML that is currently on the page. Here is our punch list wrapper that wraps everything. Here is the row that we happen to currently be in. Here is the 3 divs, hi mom, hi dad, and this first one. Inside this first one, Now again, you'll remember that as we looked at our code, what we wrote in there was a tag called image. However, because image is a component and it has its own answer to the question, how do you draw yourself, its answer is that it's going to return a div of class MSImage. So we don't actually see the image tag right here. This has been compiled. This has been developed into its own element, and that element has been put on the page for our browser to render. And we'll also notice that it's not just a single element. It has a child element within it as well. So there's a div of type of class MSImage, and inside of that we have an image. That image has a class and it has a source. Source is localhost, dist, yada yada. So my first guess on why this isn't working is because that path is not correct. So let's go ahead and take that source, stuff it into our browser. And there's our image. So we know the path is correct. Let's continue our debugging adventures. Oh, here's our problem. You remember how earlier I said I didn't like this class name, I didn't care about it? Well, one of the things that was solving in my other code is getting it to actually show. So here we have a div, and if we go look at the dimensions of this div, it is 229 pixels wide, because it's part of our grid, and our grid is saying take up 1/3 of the space, and so it defines its width for it, but it is 0 pixels tall. And that's why we're not able to see exactly what's on the page right here. So we'll go ahead and add this back. We'll say we're going to define a style called logo image. The way that we do that is we come into our module.css. Underneath our punch list wrapper, we're going to create a new definition called logo image, and we're going to give it a height of 100 pixels. Something else to consider is you'll notice that in our code we just called this punch list wrapper, row, third column, but when it actually gets put out on the page, you'll see it is punch list wrapper with a bunch of numbers after it. Ooh, where'd I go? Punch list wrapper with a bunch of numbers, row with a bunch of numbers. Now you know how I told you that SCSS is very good at keeping the elements independent of each other? If we were to define something in this component called a third column or called a grid, and then we had another component on the page that also had a definition for grid or row or something like that, it would be grid underscore a different set of numbers or row underscore a different set of numbers. So even if I didn't wrap everything under punch list like it is right here, let's say that I got rid of that and I just had logo image. And as we know, because I copied this from our budget reallocation also has a definition for logo image, because when it gets compiled and it gets put onto the page, they each have separate, unique numbers after them. They would not interfere with each other. So I could have a punch list on the page with a logo image and a budget reallocation on the page with a logo image, and they could even be different. Let's say that the punch list needs to be 200 pixels high and the budget reallocation only needs to be 100 pixels high. It would still work because we're using SCSS instead of standard CSS. And in the compiling process and pushing that out to the page, it handles all the localization for us. So you'll notice now we have our image. It's 100 pixels wide. Congratulations. Now we're going to go add some buttons. We said we were going to leave our second one blank because we don't want to worry about that right now. That was just part of what we were doing, so we're going to go ahead and leave it blank. And for our third one, we are going to go put those buttons. Now, when we were developing the buttons, we knew that they were going to be shared pretty much among all of our forms. So again, in the style of having common components, we have created a common component. You'll again remember in our source, common components, we have a number of different components that we can use right here. One of them is a save button. So we're going to create another child component. Let's see, what's the name of this? This is a class called mySaveButtons. So we'll go ahead and create a component called mySaveButtons, and we'll have it close itself. Again, it's going to be like, hey, I don't know what mySaveButtons is. So we'll do a control dot, import mySaveButtons, and now it knows what a mySaveButtons is. Now, how do we know what we're supposed to pass it? How do we know what sort of components that it wants? Well, very similar to this, that as it was rendering, it wanted a punch list property. We can come in and look at our common component over here and see that it wants a save button property. What is a save button property? We'll go ahead and click on that and hit F12. And a save button property has 3 different things that we can send it. Now you'll notice that this definition looks slightly different in that there is a question mark after each one of these. So this is saying you have a property called useIcons, but it's not strictly necessary. They can leave that one out and we'll be okay. And as a programmer, as somebody who wrote mySaveButtons, I just have to be able to deal with that properly inside of my code. If they have it, if they don't have it, let's figure out what it is. I can use borderless, which I kind of like, so we're going to go ahead and use that. So in my mySaveButtons right here definition, we're going to say use borderless equals true, and we'll come back over here and button definitions. Button definitions goes a little bit beyond the scope of what I'd like to try and cover today, and so for the reason of expediency, and because we're doing this a lot anyway, I'm going to come in here to our budget reallocation, look at the code, find the definition of mySaveButtons, and swipe it. So we are creating a private variable called button options. We're going to tell it that it is of the type mySaveButton definitions, and we're seeing a red squiggle right there because it's like, I don't know what a mySaveButton definitions is. So our first answer to that is always control dot, add the definition. Haha, we're fine. Again, we come over to this one. It says, hey, I don't know what a myButton type is. So again, we'll try control dot, add it to the existing definition. Haha. And I'm going to clean this up for just a second, and then we'll get back to what we were doing. Okay, so now we have it a little more cleaned up. It's a little more readable. And essentially what we have is we have a save button definition. We have an array of them. That's this notation right here. So we've got a bunch of save button definitions, and they each basically just have 2 things. What type of button it is. So this is a close button, and its label is close. This is a save button. Its label is save. This is a save button. Its label is save and close. And this is a submit button. Its label is submit. So we'll go ahead and take all of these button options. We'll pass it in here. So what are the button definitions? This, button options. And because we're reusing a lot of the code that has been used in the other files, in the other forms, and the other things that we have done, this should be pretty much all we need. And now we have 4 nice little buttons over there. They don't do anything currently. That was all the stuff that I cleaned up a moment ago, but at least we got them rendering on the page. So some of the key takeaways that we had from this particular section. What is a render function? What is an element? How does it work? How do we include previously written components, such as the Microsoft Frameworks image tag? How do we use components that we have written, such as the mySaveButtons? How do we use the grid functionality? And essentially, how do we get some really, really basic stuff onto the page? See you in the next section. In this next section, we're going to talk about how to get project information. Most specifically, we're going to be talking about how to use services, shared services that we have in our particular project, very similar to what we just did using shared components This is just going to allow us to use some shared code within our current component. So let's go ahead and switch back over to our code and look at our example. What we're going to be doing is this form is going to be tied to a specific project number, and when it loads up, they're going to want some information about that specific project. For example, they're going to want the project title, the project number, and the project manager to display on the screen. So we'll go ahead and make that happen using some of the shared services that we have created. So in our render function, we're going to change things up just a little bit. In order to give us a slightly better understanding of how this page is laid out, rather than having the row definition be within the header row, we're going to move it out here. So we're going to say div class name equals common styles row, and then that row is going to contain our header row. What did I do? Oh, I didn't close the div tag. And then we can just take this section right here, copy it, paste it down again. So we're going to have another row as part of our main render function. And in this one, we're going to render our project row. And to make sure that we don't have two rows within each other, we are just going to remove the class from this. We still need to have that div there because, as you can remember from before, anytime we're returning a JSX element, we have to return a single element, so there needs to be some kind of wrapping div to encase these three column divs, but we don't actually have to do anything with it as long as there's a single wrapper. So let's, again, copy and paste as our friend. So we'll finish that off. We're going to create a new function called render project row. It is going to be a function that takes no parameters. It is going to return a JSX element, and right now we're just going to return our wrapping div. Now, as you remember from our example, there are two rows within this row that we're in right here. So we have this project information section. It itself is a row of the parent grid, but because we want its information to be on two rows itself, we are just going to go ahead and make ourselves another grid. So within this row that we are currently in, we'll make us a grid. That grid is going to have two rows within it. And this first row, we are going to have project title. And on the second one, we're going to have project number and project manager. Again, if we have a grid and we have a row, we need to tell it how many columns this is going to take up. From our example, we can see that on this one, it takes up the entire column of itself. So we'll create yet another div inside that. And this is going to be a full column. And we need to know how many columns these two are going to take up. So we'll wrap that one in a div, we'll wrap that one in a div. I feel like I didn't line that up properly. Oh, there it is. Okay, now that lines up properly. And you'll notice as we come back in here and look at our example, this is not quite 50-50. This is not halfway across and halfway across. Putting it halfway across means that Project Manager would start right about here, which it does not. So I'm going to guess, for the sake of this, that this is about 1/3 of our available space, and this is about 2/3 of our available space, and so we'll define these accordingly. Our project number is going to be third column, and this is going to be 2/3 column. Title here, number here, manager here. Again, keeping with my philosophy of never write too much code without at least testing it and make sure it's getting close. We'll go ahead and save that, wait for it to re-render, and then I'm keeping an eye down here so that I can see, whoop, there we go, starts its re-render, and we have project title, project number. That's on its own row. Those two are each on their own rows. Looks pretty good so far. So now we actually need to go get information from SharePoint. We need to know what is the project title, what is the project number, and what is the project manager. But before we can go and get that information from SharePoint, we need to know ourselves. What about this page right here tells us what project we are associated with? Currently, there is nothing. So the answer that I'm going to give for that particular question is we are going to put a query parameter up here in our URL. So we're going to say project number, or projnum equals, and we're going to use our standard testing project 400, 300, 200. So now there's at least something on the page that tells us what project we are interested in. But how do we get it? Well, in order to get that information out of the query parameter, we are going to build ourselves a little helper function right here. It's a private helper function. We will get query parameter. That is going to be a function. It is going to return us a string. And we use the fat arrow to define it as the following. Now it's yelling at us because it wants to return a string, but we're not returning anything yet. That's fine, but we're going to treat this one a little bit differently with our query parameter. We are going to pass a parameter into the function. That parameter is essentially going to be what query parameter are we looking for. So we'll call this parameter, I'm using parameter a lot, I know, I'm sorry. We'll call this parameter param name, and it itself is a string. So this gives us a slightly different look at these functions. So rather than just doing a blank function with no parameters into it, this is expecting one parameter, and it's going to return us a string. Now, what are we going to do with this? How is it going to get? We're going to first get all the parameters that come from our query string. Maybe we should call that instead var query string. And the way we're going to do that is by using a React function called URL search params. So we're going to go up into the query string. We're going to get everything essentially that comes after this question mark right here, all the query parameters, and we're going to stuff them into this variable. Or rather, we are going to make an array out of them and then stuff that array into this variable. Now it needs to know kind of what search parameters we're looking for, so we're going to use regular JavaScript. This can be done in JavaScript or TypeScript right here, so if you're familiar with JavaScript, this might look familiar, but we're going to go to our window. We are going to look at the location, or the URL bar, and we are going to get the search parameters out of that. So this is going to return us a big long query string. We're going to turn those into an array of search parameters, and then we're going to stuff that array into query string right here. Now you'll notice that when I created var query string, I didn't give it a type. Because TypeScript is built on top of JavaScript, you can do anything that JavaScript could normally do. As I said earlier, JavaScript is a loosely typed language, and so it doesn't actually care what your variables are. Because we're using TypeScript, we care. But in this particular case, just because I didn't define it, it's not going to freak out at me. It's just going to treat it like a JavaScript variable and essentially say, oh, you can stuff anything in there that you want. There's some advantages and disadvantages to this. The advantage is that I don't know what URL search params gives me. Or rather, if I mouse over it, I can see that it might give me a string, it might give me another search params, it might give me an array of strings, it might give me a tuple of strings, I don't know what it's going to give me, and at this point I don't really care. So I'm just going to let that be whatever it is. The disadvantage is that now if I go to use this query string and hit dot, it's not really going to help me out very much. It knows that it's an array of something, and so it gives me the general array things that you can do, like append, delete, get, set, that sort of a thing. But since it doesn't know anything more than this is some kind of an array, it doesn't give me a whole lot of help. So that's the advantage and disadvantage of using TypeScript. When you use TypeScript, it's really great because it can give you a lot of help. When you hit dot, it can tell you that you're assigning something to the wrong type. And it can give you all sorts of, yeah, the dot, I already said that. But that doesn't force us to use the TypeScript functionality. We can just use regular JavaScript anywhere that we really want to. So the one I'm interested right here is from the array. Let's get the one called, what do we call it? Project number, and we'll just return whatever that get gets us. So this is going to go to the window, search, make URL parameters out of it, and then we're going to get the one called project number. Now that would be good if we knew for certain we were only ever going to get project number, but since we don't know that, we're actually going to use this variable that we passed in right here. So it's going to return whatever query parameters match what we pass in. So where are we going to use this? I mentioned earlier that every single React component must have a render function. But that is not all the cool things that we get from React components. One of the cool things that we get that is optional is a function that is public, and it's called component will mount. Now you remember I've been saying before that the way that these React components work is there is a parent, and the parent grabs the child and says, hey child, do your thing. And then that child might grab other children and say, hey children, do your thing. Show me how you write yourself to the screen. Show me how you write yourself to the screen. Show me how you write yourself to the screen. Well, at the moment that happens, at the moment the parent says, hey, write yourself to the screen, it does what React calls mounting that component. This happens immediately before that. So the parent says, hey child, draw yourself. And the child says, hey, before I draw myself, I need to do a little bit of work. And that happens right here in the component will mount function. We don't have to necessarily write that anywhere. It's part of a React component. So inside the component will mount, we're going to do var project number, and that is going to equal get query parameters proj num. So now we at least sort of know what project we're looking at. So if we were to come to this page with this project, in our code we would now know that we are looking for project 400, 300, 200. Now how do we get project information out of that? Well, as I mentioned earlier, we are going to use shared code. Because this is something almost every single form that we will ever write is going to need, we have broken a lot of that logic and a lot of that helper out into this common services folder. So we had our common components folder. So we have a currency field, a people picker, the signatures, the save buttons. All of those things are components that we put on the page. Inside our Common Services folder, we essentially have reusable code that's not necessarily going to write anything to the page, but it's going to help us get there eventually. In this case, we're looking for information about that project. We're looking for project 400, 300, 200, so we are going to use a project service. So we'll come in here, we'll say this is a project service, so we'll go create us one in our code. Right here in our definition. So we're going to create a private variable called a project service. It is going to be of type project service, and the way we're going to create it is by making a new project service. Because this is private and I want to keep my convention going, I'm going to put an underscore in front of it. Oh, and I just realized I did not do that with my buttons. Let's put an underscore in front of the buttons as well. And that is going to get mad at us because we used those buttons somewhere and now we've changed the name of it. There we go. So this underscore buttons. So the first thing it's yelling at us is, hey, you're using a type called project service. I don't know what that is. And the way that we generally answer I don't know what that is control dot import. Congratulations, now we have it. The next thing that we see right here is, hey, when you make a new project service, it requests two things in order to make it. It requests a web part context and the title of the project list that we're going to go get our project information from. Now this first one should look very familiar, a web part context. You think to yourself, hey, we have a web part context. We got that from our properties. So the first one's going to be very easy to fill in. We're going to do this, props, context. Congratulations, we got it. The next one, however, I'm just going to magically type in here because I know that all of our projects are stored in a SharePoint list called projects. So all the red squiggles go away. We now have an active project service. What are we going to do with it? We are going to go ask it questions. So in here, we're going to make another variable called this project, or maybe we'll call it current project. And our current project is going to come from our this project service get project information. That is a function. Oh no, it's freaking out at us. What is it going to need? It expects a project ID, or a project number. This is going to return to us a whole bunch of information about a project. It's going to return a title, it's going to return a number, it's going to return the project manager, it's going to return how much budget it has associated with it. It's going to return a whole bunch of different things to us, but all we have to do is feed it a project number. And it just so happens we've got that from our query parameter, so we'll go ahead and punch that in here. This is going to be a string, and this is going to be an iList project. Again, don't necessarily worry about how it, whoops. Oh, this does not return an iList project. This returns a promise of an iList project. All right, we're going to do this slightly differently then. So the way JavaScript works is much like you would expect any other programming language to work. And that would be that it reads the first line of code, it does the first line of code, and then as fast as possible it moves on to the next line of code, does that one, then as fast as possible moves on to the next line of code and does that one. Sometimes, however, things take a while. For example, anytime that we're going to SharePoint to get information, this takes a while. JavaScript is not very good at waiting. So if we were to write a line of code, let's say that we had one that said, go get information from SharePoint. And that would make an HTTP call to SharePoint, wait for the result. Oh, that's cool. Wait for the result. And then give me the project number. Okay, so that's what's inside that function. Then the next line of code is var project number equals, and let's say var result equals result dot project number. what would happen is it would say, I'm going to make a new variable called result, and it's going to be the result of whatever this function is, and then it would go start that function, but then it would immediately move on. And so it'd say, okay, result.project number. Well, because it hasn't even started making this HTTP call yet, there is no project number there. It doesn't know. And so it would just assign null or nothing to this project number right here, and then continue to move on. And then maybe a tenth of a second later, it would start this HTTP call. 2 seconds later, it would get the result. And then it would come back and say, okay, now I have a project number. But JavaScript is already like 15 lines down. It doesn't care anymore. It stopped caring a long time ago. So there is a tricky thing that we can do in JavaScript that helps us to force things to wait, and that is called a promise. So in that example we had before, instead of just saying call this function and then move on with life, we could say this function is a promise, and eventually that promise will have a project number in it. And so when it gets that project number in it, then we want to move on with the rest of our code. The way that that actually looks in code is like so. We know that getProjectInformation is a promise, and it promises to eventually give us an iList project. So how do we tell it that we want to wait? We say, well, go start your promise, and when you're done, or then is the keyword that we'll know. So go call this function. When it's finished, when you have your iList that you've promised us, we're going to do something with it. So we're going to call project. We know that it's going to be an iList project because this promise told us it would be. So we're going to create another function right here that says when you're done, pass that function an iList project, and fat arrow, define it as follows. So we'll have a variable called project, and that will be the project that we have from here. So again, just kind of a brief recap. We have a service. That service has a function. That function is a promise that eventually, at some point, it will give us an iList project back. Once we get it back, we pass it to this function, and then this function does things with it. So JavaScript can still behave like JavaScript. It can go run query parameter and give us that number. And it can go run this function and move on with life. And once this is done running, it can run another function. I mean, we could even define that as a function. I'm done with promise, yada yada, and we could even like pass that right here. So we could say, once you're done with this one, then go run the function I'm done with promise. But instead, we're just kind of shortcutting that and saying, run this anonymous function. It doesn't have a name, but it will take a project and do this with it. So the code in here will not get run until the promise is completed, and the code out here will happen immediately. Kind of confusing. If you have any questions, let me know. But we're going to move on. So we now have a whole bunch of information about our project. Now that we have it, what do we do with it? Well, we want it to show up in our project row, right? So we have this variable up here called project, and we want project.title to eventually show up right here. How are we going to do that? We need some sort of mass variable that we can pass around in between all of these functions. Because at some point the render is going to call, it's going to try and render this, and it's going to go here. So there's really no way that we can get from the component mounting and use this variable inside our render, because they could be happening at very, very different times at very, very different places. Well, see how good your memory is. We set something up back in section 1 that I said would become very useful later. And that is, in our properties, we created a state. And that is essentially the answer to what I just asked. How can we create a big collection of data that we can pass around anywhere inside of our component, and we don't really have to worry too much about that, and that is our state. So inside of our state, we would like to have a project variable, and we know it is going to be of type iListProject. Again, you'll see my IDE was very smart. It said, hey, I don't know what an iListProject is, but it was able to find one right here, and so it just went and imported it. And we're also going to use that other fun notation that we learned, the question mark, to say, maybe the state will have a project, maybe it won't. We don't really know. And so we'll have to code around the fact that we don't know. So, coming back to here, instead of just making a random project variable, we are going to set that variable in our state. Another fun thing that we get from all React components is a properties list that we've seen sometimes as this props. We also get a state list that we will see as this state. Now the properties list is defined as an iPunchlistProps, so we'll define our state as an iPunchlistState. What's our error? Oh no, I don't know what it is. Well, how do we solve I don't know what it is? Usually it's control.add. Hey, problem solved. So we want to set our state right here, so we're going to say this, meaning our React component, and it's going to have a built-in function called setState. That function takes an object. Our object needs to look like this, like an iPunchlist state. So an iPunchlist state only has one thing, a project. So we'll say our project, and what is the definition of that project? It's a project. So again, when the component mounts, it's going to go to our query parameter and get a project number. It's going to go to our project service and ask it for the project information and wait. It's a promise. It will eventually get back to you. I promise. I promise I'll get back to you. So we'll wait for it. Then when it's all done, we'll take that project and assign it to our state. And then essentially down here in our code, we can just say this state project, which is the variable that we just created. And because it's an iList project, and we defined that it's an iList project, it's got a whole bunch of information available to us. Because we're interested in the project title, we will add the project title. And we'll do very similar things here. So our project number, whoops, too many brackets. There we go. Let's try number. There we go, project number. And the project manager, let's see if we can get again, something that's very specific to us, not necessarily specific to React or TypeScript or framework, but this is just us, that you just kind of have to learn or know or whatever, is that when they were initially setting up this list that we're getting all of our information from, they did not call the project manager a project manager. You think that you see that right here, but you don't. This is actually a program manager. And so in order to get the project manager, we have to use the name that they were originally using for a project manager, and that is SPM assigner. Again, I don't know why. I don't know how it got to that, but yes, SPM assigner is the project manager. And this SPM assigner is of type person, and so if we tried to write that to the screen, the web browser would freak out at us and say, I don't know how to write a person to a screen, but a person also has properties, and one of those properties is a title. And we can write a title to a screen because the title is a string. Project number is a string, project title is a string, and our program is really good about writing strings to the web browser. So again, we don't want to write too much code without testing it and making sure that it actually works. So we'll wait for this to rebuild. And after that is done rebuilding, we'll bring it over here and refresh. And we notice a small problem. There is nothing on the page anymore. So let's go through some debugging steps and see if we can figure out exactly why it is that nothing has shown up on the page. So I'm going to hit F12 to bring up the debugger console that we have, and we see that currently there are 6 errors showing up on our page. So what I usually like to do is scroll up until I can find the first one, because that will often lead to other problems that show up later. Unable to get property project. Let's go ahead and click on this link and see where it's taking us. Render project row. So inside this function here, render project row, at some point it's trying to get access to this .state.project.title, and it's telling us that when it attempts to do that, project doesn't exist. And because project doesn't exist, it doesn't have a title, and so the whole thing blows up. So now we have to ask ourselves the question, how would we find ourselves in a place where project doesn't exist? Well, I've kind of hinted at it as we've gone through this before now, but we'll go through it kind of step by step and see if we can figure out together why it's doing that. So here's our code inside of Visual Studio that takes us to the same line that we were just looking at. Here is state project title. And so this is the line that we know we're having a problem. That gets called by render project row. That gets called by our render. So what situation could we get into where project does not have a title? Well, if you remember me talking about promises and how they work before, JavaScript likes to just go from the top of the page down to the bottom of the page and run as many things as it possibly can. At some point in this process, we gave it a promise and said, eventually, we'll get back to you. But we're not going to right now. And when we did that, JavaScript said, okay, great, time to move on. So here's what's actually going on in the background. When this component is being mounted by its parent component, it runs this function right here, the component will mount. It gets our project number, and then it gets this promise that says eventually this is going to return and give us a project, and then we're going to put that project in the state. But JavaScript looks at that and says, okay, eventually you'll do that for us, but in the meantime, I'm going to keep going. And so it continues to run on with its merry way. And it starts to call our render function, it starts to call our render header function, it starts to call our render project row function. It gets in here to project row, and it manages to hit this line well before this promise ever comes back with a project. So by the time we get here, there is still a promise out there somewhere waiting that eventually state will have a project. But at this exact moment, it doesn't. And so then when we ask what the project's title is, JavaScript says, well, I don't even know what the project is, and so I'm just going to freak out and not show anything. So we need to put some kind of error checking in here to say we really don't want to run this render function until after we know that there's a project in there. Now there are better ways of doing this, but for the sake of expediency and what we're going to do right now, I'm just going to put an if statement at the top of our render function right here. So if we do not have this state project, then we're just going to return a div that says waiting for data. Again, I would probably not leave this in production code anywhere, and we do have a better solution that I might get to in section 5 or 6 of this discussion. But for now, we'll go with that, because at least then we'll be able to see something on the screen that tells us exactly what's going on. So let's wait for we saved it, so we'll wait for our code to recompile. And if everything goes according to plan, when it first pops up, we should see this waiting for data, and we do not. So let's go again to our debugger tools, find the first error that we run into, unable to get project. So we're still getting the same error. Let's see where it's... That's interesting. Let's put a breakpoint right here in our debugger and see if we can figure out what's going on. State is null. Well, that would be why it can't find project, because it doesn't even know what state is. Oh, I forgot a step. Yes, this makes sense. Okay, so let's go ahead and fix that. So as I said, because we are using the React component type to make this particular class, they all must have a render function. That's just something that it has to have, or it will not work, it will not build, it will not compile. But they have other functions that are available to them as well. One of those other functions is component will mount. We saw how that gets used as we're putting the components onto the page. Another one is, as with most classes that are out there in strongly typed languages, object-oriented languages, there are constructors. So, for the sake of expediency, and because I've done this before and I don't want to have to rebuild the wheel, we're going to go look at the constructor from another one of these that I've built. There we go. And we're going to steal this part of it. Oh, there we go. So we have a constructor. This basically means when the component is first being built, before it even mounts, before it even renders, as soon as the very first line of code gets called that says, hey, give me a new punch list, this will immediately run. This helps us set up some initial things such as a state that are needed in order for our class to function properly. So the first thing that we get is a set of properties. Those come to us from our parent component. And we are just going to, I guess you could call this a magic incantation of some kind. You just kind of have to know that this is there. If you leave this line out, it won't work properly. But we're going to take whatever properties we get passed, and we're just going to pass them up to whoever is calling us. So eventually, React has a base object that kind of kicks everything off, and it passes properties down, and then that component to another component. That component passes them down to another component. That component passes them down to another component. Eventually, it reaches the bottom, and then to make sure that everything worked all the way down to the bottom, it needs to pass that information all the way back up to the top. Otherwise, nothing happens, nothing gets rendered, and this is what facilitates that. We got passed a set of properties. We're going to make sure that those get passed back up the chain when we're done. And so if that doesn't make sense, that's fine. Just remember that all constructors need to also pass the superprops. Now, what are we interested in? We are interested in our current state. We have to initialize our current state, otherwise we'll run into an error where anytime we ask for this state, it won't know what we're talking about, which is what we just ran into. So in our case, we have this state, and remember, our definition for our state is defined by punch list state, so we can go look at it, and it says we have something called a project. We may or may not actually have a project. And so you'll notice that as we're looking at this, there's no red squiggles, there's no problems, there's no anything, because it says we need a state object that is of type punch list state, and it may or may not have a project. Well, right now it does not have a project, and so it thinks everything is good. If we wanted to, we could go in and say, no, it absolutely has to have a project in order to work. And then we'll notice that we get the red squiggles right here saying, hey, this is supposed to be of type punch list state. Punch list state requires a project, and you don't have one. So let's go ahead and give it one. Part of our shared service that we have with our project service is a nice little placeholder that I use in many, many places. And we're going to do the same thing here. So we're going to say the initial project that we get, that we initialize this object with, is going to come from our project service, and it's just going to be a blank project. That's just a variable that I have defined in our shared service just in case we ever need it in situations like this where I have to have a project but I don't really care what's in it. This will just satisfy the needs of having a blank project. But now that causes problems with our error checking that we did right here, because now when our object, when our class gets constructed, it is going to have a blank project in it, which will satisfy the demands of this if condition. So we can no longer say if it doesn't have a project, because it will always have a project. Either the constructor will give it a blank project, or in our component will mount, we will get an actual project that will come back. And so this is not a good condition anymore. Something that I know about my blank project is that the blank project always has an ID of -1. I use -1 a lot of times in my code to say this is just kind of a placeholder data, but it's also a way of error checking. So we're just going to modify this a little bit. So I'm going to say if the project that we have has an ID equal to -1, then go ahead and give us this waiting for data. So theoretically, what should happen is when we reload our page, when we save it and reload, it should initialize the project to blank project. It should hit this condition right here and put on the screen waiting for data. Then when this promise resolves, we should call set state. We'll get an actual project in there. As part of setting a new state, it will call a new render function. It will then pass this and go down and show us the data. We will remove our breakpoints in here because we don't need them anymore, hopefully. And we'll see if what I predicted came to pass. There's our waiting for data. And we got an error because I'm on local workbench. So now because we're going to actual SharePoint and getting actual data in our get project information, we need to be on an actual SharePoint page. This particular page that we're looking at right here is on my local host. So when it goes and tries to find the project list on localhost, it fails in a spectacular fashion. So we're going to go to the actual workbench that is on our Salt Lake City SharePoint site. And we will try this again. We'll add our punch list project. Oh, you saw that there, waiting for data. And now we have actual data coming from our actual SharePoint list telling us the project title, the project number, the project manager for project number 400, 300, 200. If we wanted to test that this was actual getting real live data, we could put in a different project number. So we'll put in 400, 300, 201. And you'll see that this data now changes. Test project 2, project number 201, and the project manager is Emma McGowan on this particular project. So this is how we use a shared service that I have created. We have a person service and a project service right now. I'm sure there will be more to come later. But right now we are using this shared project service, bringing it into our code, using a function from that to go get project information and render that project information onto the screen. So, that being completed, we'll move on to our next section.